All right, we're going to go through a problem here. This is another common free response question. It's under the random variables section. There's a separate section for probability. Random variables and probability they kind of overlap a lot, so they kind of get mixed together. So there's going to be plenty of probability in random variable questions. And here's an example of one with probability in it. So this is number 5 from last year. A company that manufactures smartphones developed a new battery that has a longer lifespan than that of a traditional battery. From the date of purchase of a smartphone, the distribution of the lifespan of the new battery is approximately normal, with a mean of 30 months and a standard deviation of 8 months. For the price of $50, the company offers a 2-year warranty on the new battery for customers who purchase a smartphone. The warranty guarantees that the smartphone will be replaced at no cost to the customer if the battery no longer works within 24 months from the date of purchase. In how many months from the date of purchase is it expected that 25% of batteries will no longer work? Justify your answer. So this question is essentially asking, what is the 25th percentile of the battery lifespan? Okay, so I would go about this and say, all right, well, we're told, let's read this carefully, we're told that the distribution of lifespan of batteries is approximately normal. Sorry. So I'm going to go and just sketch my normal distribution here real quick. And we're told that the mean is 30 months. And we want to know what is the 25th percentile. So what we want to do here is say, all right, if I were actually probably be a little bit more like right here, a little further along. If I were to say, all right, this is my proportion, I want this proportion to be 25%, and I want to figure out what is this score. That's what I'm looking for. What is that score? Okay, so hopefully this triggers that if I know the area and I'm looking for the score, this is the inverse normal function. So I can do inverse normal. And in fact, before I even do that, I'm going to use the mean and the standard deviation. So here's mu, here's sigma. So I would note my normal distribution is a normal distribution with mean 30 and standard deviation of 8 months. So when I do inverse normal, it's going to ask me in the calculator for the area. And I know my area is 0.25. And that's going to also want to know what's the mean of the distribution I'm looking at, and what's the standard deviation of the distribution that I'm looking at. Okay, and this is effective mode. This is an effective method of showing your work. If you look through the rubric, it will indicate that showing this is a way of showing your work, and then showing this is a way of showing your work. They're both acceptable. I would do both to really verify that you know what you're doing here. There are different ways of getting to the answer using tables and other z-score computations, but this is the most straightforward way I feel. So anyhow, we would go inverse normal in our calculator. We can just open our calculator, and we would do menu. We want stats distributions. We're going to do the inverse normal function. It wants to know the area. We know that the mean is 30 and the standard deviation is 8. And there is my percentile, or there's the lifespan that matches the 25th percentile, 24.6 months. Okay, so in how many months from the date of purchase is it expected that 25% of the batteries will no longer work? That would be about 24.6 months. Okay, so really straightforward. Okay, that problem could take you as little as 30 seconds. And I'm explaining things as we go, but it could go much faster as you're working through the problem. And I think you guys mostly feel pretty comfortable with these kinds of problems anyway. Moving on to B, says suppose one customer who purchases a warranty is selected at random. What is the probability that the customer selected will require a replacement within 24 months from the date of purchase because the battery no longer works? So this is a similar kind of question, but reversed. Now they're saying, all right, well, 24 months is the cutoff for the warranty. So what's the probability, or what percentage of batteries won't last 24 months or will last less than 24 months? So we can say, all right, well, let's draw our normal curve again. And again, we know that 30 is at the center, the mean. It's the same normal distribution with 30 and 8. And we're looking now, instead of saying where's 25%, we're saying 24 months is at what proportion. So now we're trying to find this P. Okay. Up here we knew P was 0.25. This looks like a less than sign. Let's correct that. We knew that the proportion was 0.25. Here we know that the score is 24 months. We want to find the proportion. Okay, so this is just a regular normal CDF command here. So when we know the area and want the score, we do inverse normal, because if we know the score and want the area, that's what the normal CDF function is. So the calculator is going to want a lower bound. Well, the shortest possible lifespan for the battery is 0 months. It's going to want an upper bound, and we're concerned with the upper bound of 24 months. That's when the warranty runs out. And we know that the average is 30 months and that the standard deviation is 8 months. And now we can go right to our calculator, type that in. So stats, distributions, normal CDF, lower bound is 0 months, upper bound is 24 months, mean is 30 months, and standard deviation is 8 months. And we get 0.2265, 0.2265. So that means our proportion that we're concerned with is 0.2265. Let's think about what that means in context. It says, what is the probability that the customer selected will require a battery replacement within 24 months from the date of purchase because the battery no longer works? That probability is 0.2265. You can leave probabilities as a proportion. You could also write it as a percentage if you want. Either answer is completely acceptable. So there is our probability for part B. Part C asks, the company has a gain of $50 for each customer who purchases a warranty, but does not require a replacement. So if you buy the warranty for $50 and you never use it, they get $50 and they keep it. But if you end up buying the warranty and needing a new battery, the company has a loss of $150 because they have to buy a replacement phone, which outweighs the cost of your warranty that you paid. So they gain $50 if you don't require a replacement. They lose $150 if you do require a replacement. What is the expected value? So here's where we're getting more into that random variable. What is the expected value of the gain for the company for each warranty purchased? So we just, on Monday in class, we did an expected value computation. We know the expected value is the sum of the products of all the possible outcomes, value times their probability. That is to say, there is a $50 gain to the company if there's no replacement, and there's a $150 gain, loss, minus $150 if they have to replace the phone. And the probability of this, of not replacing the phone, well, we just in part B found that the probability of somebody needing a replacement is 22.65%. So the probability that they lose the 150 is 0.2265, which means the probability that they gain 50 is every other scenario, which would be 0.7735. Right? So if there's a 22.65% chance they lose, there's a 77.35% chance that they gain the $50. Our expected value, let's let X equal gain per phone, gain for a warranty. The expected value of how much they gain would be, well, the $50 that they gain 77% of the time, plus, minus, because they lose this value, minus $150 they lose 22.65% of the time. So there's our simple expected value computation. We can type that into the calculator. We'd have 50 times 0.7735, was it? And then they'll lose $150, 77.35% of the time. And so we would expect, let's see, Oh, that doesn't make sense to do that. They would lose the $150 22.65% of the time. So we would expect that they would gain about $4.7. So the expected value for the warranty company, the company selling the warranty, would be about $4.7, $4.70. Okay. They don't ask you to interpret this. Our interpretation would be we would expect the company to gain $4.70, about $4.70 per each warranty that they sell. Okay, and that feels like it's kind of a small gain, but when you're a warranty company, the idea is if you can sell thousands of these warranties, $4 at a piece turns into 4,000 or 400,000 or 4 million if you sell 1 million warranties. So you end up coming out pretty decently, and this is pure profit after you've already replaced the phones. Okay, so anyhow, that's our expected value computation. Definitely important for you to be able to do an expected value computation, and definitely critical that you can do normal probability computations. Okay, so there is a question on random variables with some probability.